thank you very much for the introduction. I think there's been a lot of talk around digital twins in various forms and shapes. And that's one thing which we've seen kind of cutting across any kind of view of a digital twin. We think there's one piece which is really missing from all of them, right? Now, just in case you haven't really heard about digital twins, let's just get a quick definition out of the way. So what you see up here, it's a virtual replica of a physical object and the processes that it executes. This is kind of a universal definition. Now, you're going to get different flavors of this depending on who's talking to you about digital twins. If you talk to some of the engineering information management software companies, you might get a story which says, look, visualization is really the big thing. And you need to start right from the cradle of when a facility is born and take it all the way through to its grave, right? You talk to an OEM equipment manufacturer, and the emphasis might be more on deploying preset blueprints for multivariate analysis for all kinds of equipment, turbines, compressors, pumps, etc. And an operations-oriented company may say, well, really, digital twins, they're only going to work well if in a gray box setting where you combine them with a physics simulator and some kind of pattern recognition network. So all kinds of flavors out there. And I think every one of them has got truth in them. But there's one piece which is missing across all of them, right? So, but before we get to that, do you need to even worry about digital twins at all? Well, if you look at what any kind of facility operator is pursuing, it's really three primary things. On the y-axis, as we see on this chart, you are trying to improve as much as possible throughput and safe operation of your facility, and you want to do that at the lowest possible cost, right? So just take note that low and high on the y-axis go from top to bottom, and high and low on cost go from left to right. Okay, so if you are operating within the suboptimal area on this chart, you can improve throughput, safety, and cost all simultaneously. And as you move outwards and eventually hit that orange curve, which is what we call an operational excellence frontier, that's it. You can't improve all three simultaneously anymore. All you can do is move along the curve. You can make trade-offs between the three elements, but you can't push all of them up anymore. And this is where digital twins come in. Digital twin technologies really push that OE frontier out to the green curve. Okay, and the way it does that, or the reason why it's able to do that, it's simply making information which was previously locked up in silos or not being used as efficiently, now available to you to make better decisions. So it simply improves data-driven decision making. Okay, so yes, you do need digital twins, but we've seen again now. You come back to the story of how do you build that up, right? So I'm going to let Hassan step in here for a bit.
So in terms of designing and then putting in place the digital twins, ultimately where the pain point is that, yes, we can run a lot of pilots, but it's very difficult to scale those pilots across the whole enterprise or systems. Now, as we think about the challenges, and I'm sure many of you are also have or perhaps have embarked on a digital transformation program, be it AI, be it digital twins, there are three kinds of major challenges or weak links that we see. Number one is to do with strategic alignment. Number two is to do with the ways of working. And number three is really to do with the data. So what I mean by strategic alignment is it's really around not having a clear alignment between the technology route and the strategy that the business is pursuing. Or it's really that sometimes the technology is trying to solve a problem, but it's really not moving the dial. Those sort of issues are often a weak link in the endeavors. On the organization side, I'm sure many of us have seen, the organization is not configured properly, the ways of workings are not there, or culturally people are not tuned to doing testing and learning kind of environment. So those are kind of common, and people can solve for those three. Now, ultimately, where things fall through, and this is where we think is the missing link, is on the issue of the data. Because trying to build a digital twin, one requires a number of disparate sources of data to come together. This could be text, this could be images, and typically, if it's a brownfield plant that has been existing for a very long time, these text information will be residing in a very old hard copies documents, which are very difficult to get hold of, let alone digitize. So we believe that this itself is the missing link. And the job of Cenozai here as a startup is really to crack that and make something out of it.
Right, exactly. And so, as this picture shows, what's typically happening on all of these pilots? Well, what we've seen is the focus is really very much around sensor data, predictive maintenance, sensor data, time series, right? So let's look at the situation here. You've got a pump; it's all sensored up, and you've plugged in some OEM's super duper multivariate analytics algorithm, and sitting at some point in time now, you have a prediction that that pump's going to fail in about 3 weeks' time. All right. So what's a facility engineer going to want to know when they see that predicted failure? Well, it's stuff like this. First thing she's going to want to know is, am I looking at an equipment failure, or is it the sensor which is failing? Do I have some outstanding preventive maintenance work orders which I pushed out because I had to go fix something else? Maybe just a simple oil change will fix everything. Not all failures are easy to diagnose. So you're going to want to get your hands on stuff like failure modes and mechanisms. You want to know what else is connected to that pump. So if you're shutting it down with a bunch of other equipment, why not maintain all of them? What tools, what spares, what skill set do you need to set? Can you even afford to shut down and make the fix because you've got a critical production schedule running through? And as Hassan said just now, all that information is sitting in documents. It's text and image data. And accessing that by machine, that's pretty much the hardest area in machine learning. And that's why it's really missing, no matter whose perspective you look at. In what a digital twin is, it's missing across the board. And that's the piece which we're very much focused on bringing into play. And what exactly do you want there? Well, very simple to explain. What we're building is Google-like access to content. Now, specifically for facilities in the energy industry, so oil and gas, power generation, primary focus, right? But this is not a step it's not one giant step that you should jump on to try and put all of this into place. We really recommend a 3-step process, right? So first thing, basic, you want to go and get at the data which is sitting in your EPC handover documents. So this is engineering drawings, equipment manuals, etc. And 2 primary objectives there. You want to process all of the engineering drawings, create a drawing register, pick up all of the equipment, instrument, line number, tags, etc. from PNIDs and SLDs, organize all of these hierarchically and so on, and maybe put it into some kind of industry recommended standard like ISO 14224. And you're also going to want to build out your bill of materials. So that's information which is sitting in equipment manuals, spur tables, general assembly drawings, etc. And it requires the ability to extract table data. Big challenge here is most of these documents are scanned. You pick them up in paper form before, someone scanned them, you've lost track, you've lost the ability to know what files what. You've got these mega 1,000, 2,000 page documents, all kinds of pitfalls that you need to be able to navigate if you're going to actually get after this data and build this up, right? So that's step 1. Next, today it's surprising that even after all this time, the overarching paradigm for data management is document management. And what we've shifted to is a situation where you move from document to page management. So let's say you're running a HAZOP. What kind of data would your team want to pull together in a hurry, right? So probably want to get hold of various kinds of work orders, failure reports which have happened with different equipment, incidents that have transpired. Maybe there's some recommendations in SPE papers, and stuff which is sitting in other HAZOPs, FMEAs, etc. Right? Now, all of that information, the pages which are relevant to that, may be sitting across tens, even hundreds of documents. And if your team has to go through each one of those documents, find the relevant page, and then pull it up, transcribe the information, etc., that's still a pretty heavy process. So when you go to page management, what that does is you can traverse all of this, large corpus of documents, find the content on relevant pages across them, because every single page has been marked with what kind of stuff is sitting on it. And you can pull up just the relevant pages in a single window to be able to put eyeballs on everything that's that's important to you, right? Now, when we look at Google, if you were looking up something like Michelangelo, you get something which is pretty rich. I mean, this is where Google is at today, right? I mean, you look up Michelangelo, you have the primary answer coming from Wikipedia. You get a bunch of other interesting info snippets, stuff that other people look for, a bunch of thumbnails on the right with some of his paintings, let's say statues, etc., when he was born, when he died, etc., right? Try to do the same thing for facility safety, and this is what you get. I mean, this is what Google looked like 10 and a bit more years ago, right? So pretty skimpy, right? And the reason for that is this kind of information isn't sitting in the public domain. It's sitting with you. So the technology is there. The data isn't in the public domain. You need to deploy the kind of systems which are sitting within Google to be able to bring Michelangelo to facility safety. All right. Now, what exactly would you really like to do in your setting? So let's say that you've got across your enterprise all kinds of facilities, refineries, petchem plants, FPSOs, platforms, pipelines, and so on. So you've got this maintenance technician at a refinery, and she's just received a work order which is asking her to go out and change pressure safety valve, a PSV. And she's thinking, look, this is some pretty heavy equipment, and I'd like to know what kind of stuff has happened when other people have changed a PSV, so I don't make the same mistakes, right? And in fact, mistakes have been made. And I mean, hard enough to get it at it within a large facility. What if that an incident happened on your FPSO where someone cracked their finger when they were changing a PSV? How is she going to be able to find that across multiple facilities, different functional locations, etc., right? Well, you can't do that by any of the conventional document search. I mean, you can pull up as much metadata as you want on documents and so on. You are never going to find that kind of stuff. Even the stuff we showed you earlier with page access isn't going to cut it. What you really need is the ability to put across your entire enterprise a data fabric where you see you've got a bunch of nodes which have got all of the different kinds of information points that are of interest across your enterprise, and the way in which those nodes relate to each other. And that needs to be deployed within your organization. It's how Google works as well, right? And with that, you are able to have a connection between the query at the refinery and the information which is sitting on that FPSO. It's all yours, and being able to serve it up allows your people to do a much better, safer job. So coming up to the end, just going back to what we were saying earlier, that kind of the mantra around this is that you need to think big, start small, and then scale up to get to that big goal, right? So think big. I think in terms of text and image, it's pretty clear. I mean, Google is the gold standard, and that's what you want to be able to do within your organization, cutting across all of your facilities, right? That kind of access, it's the most powerful, right? You don't just pull up documents, you don't just pull up pages, you can pull up very specific information, you can get questions answered, you can get suggestions for things which you never even thought about, right? That's what is coming, right? We're already working on that. But the starting point and is to be able to get that information out of your handover data from the EPC, flesh out your asset hierarchy, build out your BOM, and move from document to page management. Now, when that's done, you need to be careful because you know your think big goal. You need to be careful that the way you fingerprint a page with the content on it needs to respect an intelligent ontology, for example, so that it feeds up nicely into what you're trying to do on the think big goal, right? And what we've done with some customers already is that starting from that point, scale up. The simplest form of scale up. There's many ways you can scale up, but the simplest form is simply to start rolling out the start small scenario, one facility at a time, right? And then once you've deployed that across the board, you've also going to have put in place the ability to then step up logically and quickly to the Google type access, right? And yeah, I mean, that's it. This is our team, mix of machine learning, full stack developers, and a small support team. You've got the information on Hassan and myself. We'll be happy to answer any questions you have, and if you can't think of a question right away, then you've got our information there, and we'll be happy to entertain you later on. Thank you.
Thank you very much.